Well, students, I believe all of you are doing good and all of you are working very hard. At the same time, be fine, be safe. Even if we need to cover up so many topics, let's go one by one. You need to do so many work along with the normal studies, and everything should be in a positive way. Study well at the same time. Keep yourself in a safe manner. Let's begin today's class. Today's class is about one or two small questions regarding the topic that we have learned yesterday. During our previous class, we have learned varieties of sets, different forms of sets, starting from empty set, then it took us to the next range, finite set, infinite set. Then we had a few numbers of examples of these varieties of sets. In today's question is something again related to the previous one, but one extra addition would be there regarding the equal sets. So the first question today is which of the following sets are null sets? Here we are introducing a word null set. Yesterday we were telling the same concept in using a different name, that is empty set. Often we are changing this wording, null set or empty set, but the concept is remaining same. Null set means empty set means null set. So which of the following sets are null sets? You are asked to find of the following group. You need to identify the empty set or the null set. The first example, set of odd natural numbers divisible by t. Check it whether this is an empty set or not. For this purpose, you need to read the question well. We have to select or retain all the odd natural numbers. Odd natural numbers will be 1, 3, 5, 7, 11 and so on. At the same time, there is a condition. These numbers, when you select odd numbers, should be divisible by 2. Which means it must be a multiple of 2. And if you observe it, you can see that these odd numbers will never be a multiple of 2. Which means apparently this set contains no element. You could select any element. So as a result here now, the first example, that is set of odd natural numbers divisible by 2 is an empty set or it is a null set. Second example, set of even prime numbers. What is that? Set of even prime numbers. When you speak about the even prime numbers means we are going to have a big collection of numbers which can be divided by themselves and only by 1. So as a result, the numbers are going to be like 2, 3, then 5, then 7, the 9 will never be, then 11, then 13 and so on. These numbers will be the prime numbers. And from this group, you need to have another quality, it must be even. So when you select again the group 2, 3, 5, 7, etc., there is only one number, that is 2 alone. So I can make a set that becomes set 2. So that set contains one element 2. Since there is one element, it cannot be a null set. It cannot be an empty set. And later you will study this set by a special name, singleton set, singleton, which means there is only one element. But this year we are not going to focus upon that one. This year we say that that set will never be a null set. Again see, set of x such that x belongs to n and 5 is less than x is less than 7. Read the question once again. X belongs to n means natural numbers. So you select those natural numbers. But what is the next condition? Those x or the natural numbers must be between 5 and 7. More than 5 but less than 7. And more than 5 but less than 7, there is only one number, that's number sets, which means that set will be having again an element, the element 6. Therefore, it is not a null set. So, in short, the first can be an empty set, second cannot be an empty set, the third cannot be an empty set. Similarly, we need to do another question. State if A and B are equal set or not equal. Lastly, we have learned about the definition of an equal set. Two sets are said to be equal only when they have the same element, exactly the same elements, which means the set A and B should be having only the same elements. Then only A and B can be equal set. Here the first case is A is equal to set A, B, C, D and B is equal to D, C, A. Remember one condition that, as we said at the beginning of this class of the set, when you write a set in any way, the letters or the numbers can be in any order, no matter in which way we are going to write it down. Maybe the first or second or the third, you can mix it up, it makes no difference. So when you look at this one A and B, A contains A, B, C and D, 4 elements. And those elements are getting repeated in B. Though the order is not same, elements are same. So since elements are same, A and B contains the same element, so A is equal to B, they are equal set. Next one, A is equal to 4, 8, 12, 16. Actually this is 4, 8, 12, 16 are the multiples of 4 only. Let's take B. What's happening for B? X says that X is a multiple of 4 less than 25. This is also confusing. X is a multiple of 4. It must be a multiple of 4 like the number 4, 8, 12, 16. With what condition now? Less than 25. So when you convert this B into roster form using the elements, you will get B is equal to 4, then 8, then 12, then 16, one more element is coming up, that is 20. So that becomes B will be having 4, 8, 12, 16, 20. Now check it out. When you compare this A and B, the elements of A and the elements of B are not exactly the same. Okay, 4, 8, 12, 16 are same. But there is one extra element in B, therefore A is not equal to B. A and B are unequal set, not equal set. If it is clear, number 3. A is equal to set of X such that X is a letter of the word school, S-C-H-O-O-L, and B is a set of X such that X is a letter of the word L-O-C-H-S. Now, what do you say about A and B? Here again, the elements are not clear, so I need to find the elements of A. So, A is equal to the set S, the first letter, then comes C, then comes H. Yesterday, we have learned that no repetition of element is allowed in a set. When you get an element is getting repeated, that is not valid, it is invalid operation. So SCHOL, not double O, only single O-L. Then the second one, when you write it down, there is no repetition. The elements are LOCHS. Now you compare it, A and B contain the same element, SCHOL, but the order is different. That makes no big change. Orders can be not different. Here now the wish. So as a result, LOCHS and SCHOL will remaining same element. Therefore, A and B are here again equal set. And the rest of the things we are going to see during our next unit. That's all for today.